luckily we bet on the right horse there, because the market has really grown, and as the topic of today shows, mobile and embedded platforms, these are really growing a lot lately, and quality requirements are also growing, and I want to talk about how to master that. For those of you who are talking only about desktop systems, I think most of what I'll say here will also apply, and so I hope we'll all get something out of it. Okay, yeah, my involvement just shortly listed. I came through the KDE project roughly in 1997. I think Martin Konal sitting here beats me in terms of that 1 or 2 years more, but that's quite a long time, of course. Okay, just to fix the topic I want to talk about, I will concentrate on the UI here, since we're talking about Qt, but that doesn't mean that we are proposing to test everything of your application through the UI itself. So if you're using QTestlib, CPP, Unit, or the Google testing framework, that should all be part of your overall testing effort. I'm just talking about the higher level to make sure that the software will really run on the final device or platform. That's why this differentiation is here. We'll be talking about the functional testing, typically called black box testing, but as you will see with Qt's nice introspection API and other ways that we have taken, you can also look inside of the Qt application very easily. There's other tools available for that. That's why we just came up with the term gray box testing here, because it's not really that black of the box the tester looks at. But still, we'll be assuming the user's point of view. I've chosen a very simple standard QML application, which I'll use for practical demos, and I'll show you how to design a test case that can later be used to spot regressions inside of your application. And in order to also defend the effort one puts into UI tests, also think of positive spin-offs that you can do in terms of profiling, checking how long did certain sequences of your test take. Is there maybe a performance regression inside of your application or the server network, hardware in general? You can do code coverage based on that, check for memory leaks, so there's a lot of extra benefit that can be combined with this type of testing. But I first want to get rid of a myth here. The test automation is not exactly suitable to find all of the application bugs by itself and fire all the testers afterwards. It still takes some time to set up, and somebody has to maintain the tests afterwards. And the idea is rather that testers are relieved from the monotonous testing tasks and can concentrate on the more worthwhile and complex ones. But what I want to show you is really the best practices that one has to consider for this whole thing, because we see that all UI testing efforts, and that's not specific to Qt, it has always been true since UIs became more complex, is that the testing efforts failed after a few months or years because the tests were designed in the wrong way. In a way that new application versions, new toolkit versions, new form factors of the hardware broke the tests, and nobody was able to maintain those in a reasonable time anymore. And that's why then certain point managers said, okay, let's stop this testing effort. We are under time pressure here, get this release out, and then this whole testing setup is lying there unused. Okay, now up to the challenges. If we're talking about Qt testing here, you have to consider that until a few years ago, Qt support was mostly about Windows, several Unix variants. Mac OS was introduced at some point, but that was it. But recently, a lot of new ports have come up, and they all form their individual challenges. So quite a few platforms, and ideally, of course, you would like to have some solution that addresses all of those platforms in case you are addressing those variety. Now, there's also a challenge with the toolkit itself. Even if we're just talking about Qt only, there's the traditional QWidgets world. There's the new QML world. It's already hard to compare from a testing perspective. Then what makes it tricky, sometimes native controls are embedded, especially, let's say, on Windows. This comes up pretty often that some third-party COM component is embedded. On the Mac, you'll have the native Mac menu bar, and of course, iOS and Android and all those systems have all their specialities to it, and it's not always necessarily purely Qt. That's also something to consider. And the latest challenge, which really got dramatic also from a QA perspective during the last years, is of course the web content that gets embedded into applications more and more often. I've seen so many Qt applications that were just a giant web browser basically with a menu on top, and that's it. Or even if it's just embedding some small part to show some graphs or tables or whatever in web, it's still two different worlds. And anybody wanting to test that will suddenly notice, oh, a button in the web page is not a QWidget or a QML element. So these are foreign worlds that have to be bridged. And to make it worse, these things can turn up all at the same time. Let's say your application is first started after somebody clicks on a link on a web page, and then there's again some web content embedded, so those variations can make it pretty hard. Luckily, and that's the good news since we're all talking and using Qt here, hopefully what makes the testing task already pretty easy compared to other poor non-Qt users is that Qt itself provides a lot of abstractions already. Of course, resolutions will be different. An application on iOS and Android is not necessarily supposed to look the same way or feel the same way in terms of usage patterns, but the abstractions provided by Qt already hide a lot of details of the cross-platform aspect. So we can skip that part. All the development talks here already covered that a lot. Okay, but what are those typical means to address the different target systems that we're talking about here? One challenge is certainly the different resolution. So even if you are just talking about targeting Apple platforms, their iPhones, iPads, then the Retina resolution came up, suddenly making things more awkward again, or even orientation. So I've just brought a Windows tablet here. Depending on the rotation of the device, everything will look completely different. So just relying on certain pixel coordinates of the application is going to lead to very brittle tests. And another thing that is also problematic, or probably belongs to the top two challenges in terms of UI testing, is the timing. As you can imagine, if you write a unit test, you typically call a function and expect a certain return value, unless we're talking about some network protocol or some heavy calculation that's going on in the background. But the UI typically tries to be as smooth as possible, which means that all the elements are available to the user, but they are not necessarily ready to be used. So pressing a button may open a dialog, not immediately, but after 1 millisecond or 1 second or even longer. Other calculation results might take a few seconds or minutes to show up, but this all means that when writing a test, you cannot really count on a fixed timing. Or it would be crazy to do, and actually 10 years ago we started with this crazy mistake saying, okay, if the user made a break of 1 second, let's also have the test wait 1 second before the next step happens. But this is utterly going to fail if the hardware is under different load or hardware gets faster, software changes its speed, there's some network load. So synchronization is a really, really critical problem in terms of UI testing. And the way one usually encounters those issue, and that's what I'm going to show in some practical demos, is that one better abstracts a little bit of the GUI. It's not like every test has to know all the details about all individual dialogues showing up. It helps with some extra work that's invested to abstract some of that away from the main test. And that's the same as any C++ encapsulates. The class encapsulates some details of any objects. The same approach can be applied to testing. That's why just implementing reusable functions or even objects can help. Mock objects, hopefully a term that is familiar to you. It's like faking certain parts of your setup in a way that it's more easily testable. For example, a connection to a scanner. That's something, of course, manual testing is done with a real scanner sitting on the table, and it needs somebody to put a piece of paper on there or give his fingerprint, as one of our customers is doing. But it's, of course, much easier if you can cut away whatever your software is interacting with and replace it with fake components, be it either done in hardware or software. And if you're setting up those components, the tester can really focus on the software functionality itself. But I'll now show some practical use of that, or how it will look like. I'll first do a test development on my laptop here, but I'll later also be able to run the same test on this tablet here. Okay, so this is the IDE that we are providing. Other test frameworks might just have a scripting API where you would start implementing your test scripts manually, but I will, for the convenience, show you how that can also be done interactively from a UI. For that purpose, I'll create a new test suite, which will be a collection of test cases, and in this case you'll see all the other editions that we'll also support, like native Android or iOS testing, Mac and Java, but of course we are only concerned about Qt here. And the next choice, and that is also a recommendation that I will speak out if you're looking at any solution, is really look at the scripting support that is available. Some vendors create their own type of scripting language, which you'll be stuck with forever. And if you need a new feature, you have to ask the vendor to provide that. Some have some basic macro language where there's maybe a list of 10 or 20 commands, which look very easy to use. But if you're thinking about more complex test cases, those macros will be too limited. Or the other approach that you might sometimes see is that somebody just thinks in terms of visual scripting. So there is a nice tree and there's maybe a for loop possible or some if decisions. That looks easy first day. You might buy such a solution or maybe find some open source approach, although I don't know of any for that. But in the long term, the more complex your test gets, you will want a fully featured scripting language. And this will also free you from the vendor. There are third-party modules for database access, networking, hardware, whatever I/O, and you can even create your own abstractions on top of that, completely hiding the internals of the tool you're using and also hiding the details of Qt. So yeah, we chose to go for those standard scripting languages, JavaScript, Perl, Python, Ruby, and Tcl. Might sound funny, but I would hope that there's something for everyone among that. I'll stick to JavaScript because that's what I know best. And the next question is, which application do you want to test? So that's the point where I'll be asked for an executable or shell script or a batch file. If you are want to test a pure QML application, you would then use the viewer that is there for QML files as executable and pass on the QML file as an argument. I'll use a calculator, which I believe is a standard Qt example, and to show you that there's nothing to do about an application necessarily. It doesn't mean that each application is designed to be tested, so some applications really show some challenges, but generally there is no need with the features that Qt provides to change the application before it's being tested. Okay, I'll create a first test case here, and I'll use the approach that some people really don't like, that is just to capture a test and replay it. The reason why this is not liked is the fact that if you do that hundreds of times, you'll have hundreds of repetitions in your test cases, and if there is a single change in your application, you'll be faced with touching almost all or all of those test scripts again. So I'll just do the capture and replay approach here to give an introduction and also show how you would gradually migrate to a more sophisticated test script approach. Yeah, a colleague of mine made the example so big that it fits on a higher resolution, which the projector doesn't feature, but I'll just use the buttons at the top. Okay, let's do a simple operation here. So I'll click the 9 and the control bar at the top. Notice that mouse click. I'll do 9 minus 3. Oh, I'm already getting into trouble here. Let's see whether enter works. No. See, it's a bad application, doesn't have any keyboard support. Now I cleared that. That was wrong. Oh, that will calculate something immediately? Okay. Well, that's true. Let's do that. I'll start again. Yes, I'll take 9. Square root of that is 3. I could now end the recording, and I'll just for the purpose or sake of demonstration do that and stop the recording, and all that got recorded out of those possibly maybe 100 individual queue events that floated through the application is that a compression happened. And that compression noticed that the user clicked somewhere on a button, and it even recorded where inside of that button it clicked, just for the sake of completeness. So if the button is located somewhere else on the screen, it will be still found at its new location, and the click will happen at the same relative position in case there is some control that is sensitive to the exact click location. So there's the 9 button, and I didn't know there's a Unicode symbol for square root apparently, or some ASCII character even, or Latin 1, and those statements have been recorded. And this started with starting of the main application. And this is a simple case, but if you are having some distributed application like a voice over IP solution, you might have different multiple applications at the same time, and you could run many instances of that and have them interact with each other. But let me replay that test. It was so fast that you couldn't even see anything. I would have to fake some position here and maybe put a breakpoint there to run until that point and look at the expected results. What I did is to build in and verification into the test. The only thing I did is to ensure that a certain sequence of steps, like clicking on some buttons here, didn't cause a crash and all the elements were available, but whether the calculator worked correctly or not was simply not considered. So I'll do it better a second time. I'll create a second test case and doing exactly the same things here. I'll now insert a verification point, because that's the time where a tester who might be following some Word document or some Excel spreadsheet or just his recollection of how manual tests are usually done, the tester looks at fact, does the calculator display the value 3 or not? You might also want to check for colors and sizes and whatever, but be warned that ideally a test case should only test a single thing. It's really an ideal world, but we really warn against testing too many things at the same time. So some clients have tried to take screenshots of each screen of their application. That's okay if you want to once make sure that the application renders itself, but if you do that for everything, every test, where in this case only the square root function was of interest, you are putting far too much redundancy into your test cases, and if the designer changes the style or new cute quick version comes out, all those tests will break only because the rectangle suddenly got a different 3D effect on their corners. That's why the limitation on the real things that you want to test are important, and I will show you that by inserting a so-called property verification. And for that, we can spy into the running application, and we'll see all the QML elements, or actually it's, there are also widgets involved here. And we could dig down to those elements that are of interest to us. But in a large application, this is really a simple sample, this is going to be too much. So there is a shortcut for that purpose where you can select the right element. Let me make this a bit nicer. There's also a red rectangle that can be turned on, so you can hover over the element and you'll have that pre-selected here, and all the properties that are part of that object are visible, including their current values. And the one I want to check here is the text shown in the display, and it has the value 3 right now, so that's expected. So I'll insert that as a verification point. And I could continue, for example, clearing the result, and let's stop the test recording. So the main new statement that has shown up now is a comparison. Think of assert equals in the XUnit type style of test frameworks. And that test fetches the handle to the display element, queries it for its value, text value, and compares that to the value 3. So again, passed very quickly, and there is one positive result coming out of that. One can do that much more sophisticated, of course, like checking several properties at once, something enabled or not, a specific color, like an alarm signal that should show up on some medical device. Check for the color there, compare whole tables. So there's much more than that, but I just wanted to show you a trivial example of that. Any questions so far? Okay. Yeah, yeah. So the question is about the parameterization. That's indeed part of what I wanted to say initially, is that you should be aware of recording too much, because if somebody just goes through 10 such sequences, there will be too much duplication in there. And indeed, at that point, you should move over to something that is typically called data-driven testing. I can also show that in a bit, where you iterate over an Excel spreadsheet as an example. Yeah. Yeah. Yeah, sorry about confusing our host here, who was not prepared on early questions. How can one identify Qt objects? It's true that in the QML world, it's much easier because, at least so far, it is available at runtime and information can be queried. And let's look at a concrete example. So I'll select one of those generated names. So these are just placeholders, and I'll open that symbolic name in what we call the object map, and that's a central repository that maps that symbolic name to its real name. And what you see here is that we, after hard learning curves, decided not to only look at a single property and build a hierarchy. Like one could argue, I think Visual Basic programming was done that way, that you start with the main window, there's a dialog, there's a button and whatever. So we don't go for a big tree necessarily anymore, but a couple of properties that Qt provides are used for identification. In this case, there is the text on the button, which is a great thing. There is the type. In case of QWidget, that would be QPushButton. If you derive from a QPushButton, I know that if you call inherits or isA or something, that QObject API, you will still identify it by the base class. So derived classes also don't cause a problem for that approach. It's visible. There are applications who have hundreds of invisible toolbar buttons, for example. So that's also a criteria. And the more criteria you use, the less candidates you have for the right object. And of course, it's not that easy, because we realized even that doesn't allow you for good identification. For example, an OK button might show up in an application 50 to 100 times. And that's when we started to introduce artificial properties. As an example, there is the container property, which points to the main window, or a good identifiable main window. There are other examples. Think of an input form where somebody is supposed to enter his telephone number. there is a QLine edit in a QWidget-based application, and how to identify the QLine edit. There is no reasonable way to do that actually, because the user changes the value of that QLine edit, so it's not a good way to look up by text. But one could argue that QLine edit is next to a QLabel which says phone number. So we have something like left widget, above widget, and so on. So we also look around to find the right ones. And your question is now about the variables and all of that. We do indeed not manage to look at the C++ variables inside of an application, but we still don't require a debug build because we just look at the information that Qt provides through its introspection. So class names, object names, and I had a slide about that later. So if a developer wants to help the tester assign good object names, in QML, IDs, I know they're not meant to be public, but if a developer uses an ID, the tool can still make use of that. But be aware that not all text shown are good ways of identifying an object. Let's take the calculator and the result view on top of here. It may show any number, and that number is changing, and you better not look for that object by a number that you want to test for later. So in that case, where you have something that shows a result, you have to look for that thing first and then ask what kind of text are you currently displaying. So it depends a bit on the type of object, whether it's an input element or output element, how you identify it. There's an XML file that can be used to tune that. For QML, there's a way to write JavaScript-based extension to teach it about. So it's a complex topic, and every real-world application will have its problems initially. You will have random or dynamic objects that are coming out of a database. Something like the current date might be showing the current time, even worse, and that's something to consider when writing a test. And the solution for the changing date, as an example, would be to let me stop that first. Not insist on the text being equal to 9, but saying, okay, I'm expecting a wildcard match here, and filter out the date. As an example, our own IDE here has Squish IDE 5.1 snapshot in its title. That's a window title. You should not hard code in your test scripts, because with version 5.2 that will definitely break. And that's a case where, after learning it the hard way, because your tests will suddenly start failing when the first upgrade comes, is that you will be using a wildcard or regular expression here. Or maybe drop the property completely because it's not reliable. Okay. Further questions before I continue with some slides? No? Okay. Now a bit more on the embedded part. We see most managers, at least, insist on testing on the real hardware. That's, of course, nothing to argue against, because it's the only real thing, and a lot of issues will only surface on the real hardware because memory might be limited, or any emulation is not that perfect after all. But still, in real world, you might either have a limited number of those devices. Maybe they're not even made yet. It's also more difficult to set up the whole thing. Like, do you have to reinstall the operating system before each test run to put it into some virgin state? That's where testing on the real hardware makes testers' life more complicated. I'm not saying you shouldn't do it, but maybe consider to limit the types of testing on the real hardware to a particular set of tests, or do it more seldom. But if you want to do mass testing and you want to emulate all kinds of things like low memory, network problems, if you want to run tests on various versions of operating systems, this is all going to be much easier if you move away from the real hardware but use something like VMware or other solutions. Especially since you can boot up those emulations rather easily with a different operating system version or modify them before the test starts. And yeah, even replicate that to have a lot of tests running in parallel without purchasing the hardware dozens of times. Emulator versus simulator, it's of course also a question how good is that if you're just using an emulator. For example, iOS testing is a case where Apple only provides an emulator, and unlike Android, there's more likelihood that using the emulator is going to show some difference compared to the real hardware. But then emulators might also have nice features like simulating certain events, rotating the device, changing the resolution, shaking it, whatever. That's, of course, much easier to do with any software-based solution. Okay, I've already covered that quite a bit, I think. The warning against capture replay. I think I have another slide here. The problems, maybe I should give some argumentation help if you're talking to managers there. What we are, oh, sorry about the German there. What we are recommending, like refactoring your scripts, will cause more work initially. So you will have maybe even much more than that effort invested into your first set of test cases compared to a tester who just recorded hundreds or thousands of test cases and replays them just like they are. But the benefits will later show up on other later software versions. If the UI changes, the tester might have to re-record all their tests again or have a hard time maintaining that. And that's when the payoff of the cleaned up and refactored scripts will show up. So of course, might be that testing has stopped at that point or company went bankrupt or something. That's sometimes not easy to convince managers into investing some time or giving you some time for a proper test setup in that early phase. Actually, I recall one customer who really re-recorded all of their scripts for each software version, and surprisingly, I will say General Neutral also discovered some bugs that way, which is surprising, but I guess it was really close to manual testing then. Okay, I've talked about script languages a bit. If you go for such languages, and I think there are other Ruby-based frameworks out there. Yeah, if we also take C++ as a script language, and you of course also have Qtestlib and other frameworks. Be aware what other utilities you have available. In our case, we provide all of those languages with the same set of testing-specific languages. But if you want to talk to your hardware, to your database, if you want to set up the database before the test is executed, you might need an Oracle driver to do that. You might want to do some TCP/IP connection, and that's where all those languages, of course, have different set of features. We can speak out recommendations, but if you're neutral on that and just know Perl from previous life in Century, then by all means choose that. Yeah, choose whatever you feel comfortable with, but be aware that, for example, JavaScript is only recently developing some third-party modules that you can really use to do something outside of the sandbox, which originally was the browser. Okay, some sample on how such a factorization would look like in the end. I've, as a fictional example, taken a long recording here and moved a lot of the recorded statements into functions that I've moved into a library. So there is one convenience function for launching the application, and as an identifier, this means clean up all the settings before the application is launched. So this might mean deleting some settings file or resetting some database. Then some sample data is loaded. And behind this single statement, there could be possibly hundreds of individual function calls that choose some menu, enter some data into a dialog, set up some configuration values. But you probably see that this really gets beauty in a way, nice in a way that this is easy to understand, and even if the dialog that is used to open that data changes, you won't have to change all your test cases that do that. You'll just have the hard part to do in a single place, and so on. So there's some change of parameters, calculation, dumping the data, and comparing that in the end. And actually, in real world, it is mostly possible to condense test cases to such a high level. And this is something that also allows for splitting the work. Somebody more familiar with Qt, meaning the developer, can help to write some utility functions, like dumping the data of an example that might require some internal knowledge, and provide ready-made functions for the tester who might not have an idea about Qt or might not be so good at those scripting languages either. Next level, since we're all using an object-oriented language, in this case, this is meant to mimic Python. A typical approach for UI testing is also to encapsulate the UI pages, as an example, or dialogues into objects. And these are then just convenience functions that can be used to log in, and in this case, with the wrong password, check whether the login was really refused, which error message was shown up, try another login with a real password, and then the dialog might be hidden or show some other kind of success state. Okay, this is of course all very abstract, but I'm ready to show you how that will look like in real world. Let's first verify that the test still replays, and the question came up, how do I vary that test to not only verify that the square root of 9 is calculated properly? So instead of repeating the same sequence, we'll see how we can parameterize that. I will again look at that object name here for the 9, and now I'm going to go into more details and look at the real name in a way that we can use it inside of the scripting function. And I'll show you how that looks like. That is a property name value set there, which identifies all those properties. And looking at that, we'll see that at some point the letter 9 is used here to identify the button. And I'll make use of that knowledge and create my own scripting function, and I will first assign that still very long string to a variable. I will use the wait for object function, I'll explain that in a bit, to get a handle to that object. Oh, why is Eclipse warning me about something here? Oh yeah, that's all. I was always talking bad about Eclipse, but as an Emacs user, maybe I should be careful. Yeah. Okay, so this function fetches a reference to the object which lives inside of the application. The reason why there is also a wait here is in order to address what I mentioned earlier, the synchronization issue, because the button might not be there right away. It might take some time to show up. It might still be disabled unless the UI is activated. It might be hidden by some other progress dialog, as an example, and the wait for object function takes care of all of that. It waits for 20 seconds, I believe, by default, but if the button is there and ready to be used right away, it will also return. And more profiting what we already saw recorded here, I can now replace this one here and use a variable. And then, of course, we should be able to replace that statement there with that function call. Let's see whether I made more mistakes. No, still works. Um, explaining more items here. That's the real Qt enum that is getting exposed in case you want to use other mouse buttons here. This is the keyboard modifier, meaning whether I also pressed Shift, Control, or Alt. And these were the relative coordinates. These are optional though, so I could omit them, but let's assume we want to always click in the middle of an element. I think I just clicked somewhere without really paying attention to that. But due to the fact that the whole Qt API, not only the slots and properties, but also the C++ API is exposed, it's possible to query those and select a coordinate that's in the middle. Yeah. So there's no perfect click in the middle, although that would already have been the default behavior if I omitted all those arguments there. Yeah, that's the way to continue. I could now copy this. Oh, I accidentally did some dragging here. That's really not, it's not desired. So I took out a statement I didn't like. So I could copy this sequence here and do the same with another value and repeat like that. Okay, we are nearing end of time. To make this a bit nicer and to answer that gentleman's question, the data-driven approach is going to make writing more script unneeded. So I can create a test data file. I'll create a comma-separated file in this case. I will it's my ISP hotline calling me on my phone to sell me something. I'll set up a table here. And in this case, simple operation. So input 9 is expected to result in that value. And let's do another. Oh, let's do something simple first. Because who spotted a limitation of the function that I implemented for the pressing the button? Would it work with 81? It does not, because the function is currently only capable of entering single digits or buttons there, so one would have to, for longer numbers, more digits, loop over those and press the individual buttons. Okay, so I've created a data file here, and let's assume as a quick demo, see whether it works. I want to repeat that sequence with all the data that I've selected, and with the refactoring methods of Eclipse and something we have added on top, you can make this piece of code data-driven. So I'm selecting the input CSV. This part of the code will be turned into a loop. I think I still made some mistake, didn't specify the proper fields there. So this will probably not work. Yeah, but you can imagine if I have named the columns properly, this will now propose me to fetch data fields from the CSV file and run the whole test in a loop and not use any hard-coded numbers, but variable ones. So, yeah. Okay, but that's, or maybe just to show off, I still wanted to see how the embedded part now will look like. And this is an easy change. I'll just go to the preferences and tell Squish to not do the testing locally, but do it over this IP address of this device. Logging in. There is a daemon running here that is shipped with Squish, and that is now able to receive the commands. Let's see whether, you have to trust me, of course. We have some better embedded hardware running Android, Qt or QNX at our booth, but this is now running over the network, meaning you don't have to install everything on this device. If you're tight on memory, all the testing logic will reside on the PC where you'll hopefully have more memory than that. Okay, but I think we are nearing the end. 5 more minutes, so I'm open for questions you might have. Oh, thanks. So anything, any hard to crack nuts? Yeah.
So you were talking about the requirements for the embedded devices. Could you like extend it a little bit? You said something about installing a daemon right there, and are there other requirements you need?
Let's say for native Android, we even managed to not have anything installed, but just push the application on the device in a way that it was testable. That's this ADB bridge, which allows to do such things. For the Qt cases, the daemon does not have to be installed on the device, because you can also launch the application yourself, and instead of using start application, use attach to application, so you can connect to that IP address and remote control the application there. But still, in order for Squish to be able to remote control the application, there is some module that we call the Qt wrapper. That's the one that binds to the Qt API and can record events, needs to be installed on the device. No way around that. Further? Otherwise, feel free to visit us upstairs for some more extended demos, maybe a trial version or more in-depth question. Okay, but thanks a lot.
Thank you very much, Harry.